Okay, today I want to talk about pointers a little bit more, help that sink in a little bit. I have declared two functions here, both of which are not going to return any value, so I'm declaring them as void return type. I have one function called passed by value, where I'm passing in an integer variable. I have another function called passed by ref, where I'm passing in a pointer variable, a pointer to an integer. Now I called these passed by value and passed by ref for passed by reference. In fact, I'll change this. Passed by reference. When you read about programming languages, you might read that something is passed by value or something is passed by reference. Passed by value means that when you call the function, you are simply passing the value of the variable into the function. Passed by reference means that you are passing a reference to the variable or the address of the variable, and that's what a pointer is. So again, two functions. One of them just normal, no pointers involved. Another one passing in a pointer variable, a pointer to an integer. Then I've got the skeletons of these functions fleshed out down here. So let's say in our main I have a variable. I'm just going to call it local variable. Now when I call the normal passed by value function passing in an integer, if I say local variable equals 10, and then I call passed by value local variable, and then I put a printf in here to print the value of this variable after I come back from the function. So in our passed by value function, which receives this integer variable x, I'll say x equals 20. So when we call this, we're calling this passed by value function, which takes an integer variable and passing it the variable local variable. Inside that function, it's passed this variable. I set that equal to 20, and I come back. So when I come back from this function return and I do this print, is local variable here, is this going to be equal to 10, where we set it here, or is it going to be equal to 20, where we changed it inside this function? Well, you might think, since you're changing it in here, that it's going to be equal to 20, but the fact is, since it's passed by value means that it is passing the value of the variable here. So it is literally, when it calls this function here and it sees the value as 10 here, it's literally sending a 10 into this function passed by value here. So when we come into this function here, this function variable here, int x, this exists only during this brief time that we are inside this function. So when you enter the function, it makes space for this integer here. It does what you want to do with it, and then when you return, that goes away. So this operation here has no effect on the variable up here. So when you come out of this, you're going to print after function var equals, and you're going to get a 10 here. Now I'll build and show that just to prove that. So here you have the output after function var equals 10. So you can see that my function here, my passed by value function, where I passed in simply the integer, had no effect on the variable that was passed in. So that's the basics of passing an integer into a function, which you probably already know. Now let's talk about how you deal with pointers. So how is an integer pointer variable different than that? Well, we're going to use this passed by reference function as an example. So we're going to use the same local variable called local variable, but we're going to call a function that receives a pointer, an integer pointer, instead of a regular int. So we're going to call passed by reference, and instead of passing in local variable, we're going to put an ampersand here, local variable. And then we're going to have the same printf afterward. And inside here we're going to say star x, and I'll explain that in a second. Star x equals 20. Okay, so this ampersand is new. What does that mean? When you see ampersand, think address of. Address of. So when you pass in ampersand, local variable, it's saying passing in the address of that variable, local variable. So instead of passing in the value of the variable, which is 10, it passes in the address or a reference to the local variable. So this is passing in the actual memory address in the computer of where this variable, local variable, is located. And by passing in the address of this variable or the location of this variable, this function down here is able to operate on the variable itself. Because when you make a variable like this, local variable, the computer assigns a location in its memory to hold that variable. So let's say it's at location 1000. I'm just going to make up a number. Well, when you pass in the address of that variable, it passes in that 1000, and then this function here knows that 1000 is where this variable is located, and it can change what's inside that memory address. So when we call this passed by reference function, which expects a pointer to an integer, we pass in the address of this variable, local variable, which is a pointer to that variable. Then the function down here that receives this pointer to an integer can do this operation, star x, and set the value. So this, when it's star x equals 20, that's saying what's pointed to by this x variable, change it to 20. So let's try that. And you can see that worked because the first function, I'm still calling my passed by value function, which gives back 10 just like before. But this passed by reference function, after the function, variable equals 20. So when I do this star x equals 20, it's saying put 20 in the location that's pointed to by x. So it actually is changing this variable, local variable. So that's a real basic introduction to an integer pointer variable. I'm going to make a video soon explaining how this is working at the physical level inside the computer memory, because the essence of pointers is memory locations, since pointers are a pointer to where the variable is in memory. And if you can grasp how that's working at a physical level, it will make pointers far, far easier to understand. So look for that soon. Thanks, and have a great day.